mission has lots of time duration collecting information, sending to the research center. What are the future path, breaking and historical event plans in ISRO, which anyone had not achieved? Okay, all of us are interested to know something that nobody has achieved. Of course, it's something very difficult to see and envision, which nobody knows yet. But all of us know something, that ISRO has an ability, India has an ability to do this space sector, work it very well, and our ability generally in terms of frugal engineering and very low cost engineering. There is so much we need to yet to catch up with the rest of the people in the world. For example, in the domain of human space flight, we have not even reached that level. We have not gone to moon and landed on the moon. Americans and Russia has already gone and landed on the moon. We have not yet built a space station till now. I think we have to do that. And we know why it is important for us in the future to support the research domain in the microgravity and also to bring out economic benefits. And we know why we should go and land on the moon and create our own share of activity on the moon economy. I think all of this we know. We need to do all of that first. First, you must become equal to others. Then we will try to do something fantastic. But you don't have to wait till then. We can always do some better way of doing things. And that we continue to do. For example, Chandrayaan 3 is a classic example of, though we have not gone to moon and landed ever, but we have landed this time with a lot of world competition was going on. We were able to land on the moon very safely, soft land it. I think it's a great achievement for all of us. We must all be proud of that achievement. There are many more things that we need to do on the ground to reach out to the sky. For example, we need to find a sustained space program itself, which will run on its own. For example, we want to scale up the space activity in the economics of the space activity so that it sustains by itself. We must to create a business around the space activity so that private and partnership will come in space sector, so that there is an economic drive to make it grow. Otherwise, it will not grow, it will not sustain. Because in US, when the earlier moon program died after 1960s, 70s program, nobody took it up because there was no economic reason for doing it. Today, it is different situation. So we must find the reason for it. Then third, of course, is the strategic reasons. As a nation who is envisioning to become a powerful nation, we cannot afford to be left behind in this greater technology. So all of these are important for us, and we are trying to work out a vision for us. It's already been announced by our Honorable Prime Minister. Possibly you already know his speeches you would have heard about talking about our exploration to moon, to bring back sample, he told, and he said that we should go to Mars and Venus. We should also establish our space station, and we should also land on the moon one day. 2040 is the deadline that is given to us. So we are all working in this road towards that. But this is all certain high level goals. But there is so much of technology development that has to happen. All of this finally has to lead to. I think we are working on all of those core elements of technology which will make us to achieve these goals one day. Mr. MGR asked a question. I think it is slightly a confusing question. Is there any process of launching satellites and how final assessment is done for launch? Process. I think you may be interested to know how do we give clearance for a launch to go safely. When everything is ready for launch, how do we say, yes, now you can go? Somebody presses a button, yes, it's a go. You would have seen in movie. So we also do some press button, key, etc. But the decision is not made at the pressing of the button. The decision is made over many months of hard work. It's a systematic work. It's not done by one person. On the day of the launch, yes, it is ready for going. The decision to that is a continuous process of many people looking at every element of the rocket. Somebody who does a small control package, somebody who manufactures a part, somebody who integrates a software, all of them go through a systematic evaluation, and then at the end of it he says it is certified. And this collection of these certificates of 100 and thousands of items will come to a next level of evaluation. Sometimes there will be a deviation, and these deviations are discussed threadbare in a committee of people, and they say whether it has an implication or not an implication, and they clear again. So we go through this process of every critical look of every element, nut, bolt, software, code, and process, and then clear it at different layers of the organization. And at final level, it will come to committees like the flight readiness review, mission readiness review, and such forums are there with senior people. They will listen to the overall status, listen to the changes that has been done, they will listen to the type of deviation that occurred and assessment of the different teams. And after hearing all of this, they will conclude that all what you have done is right at this moment, and we can go ahead and give the clearance. And that time they authorize the concerned executive to do the pressing of the button. So it is a collective wisdom of the experts from multiple domains ultimately lead to the clearance of a rocket or a launch or a satellite, and that's how it is becoming successful, and it is not possible without that collective wisdom. Okay, so that's a skill that we have developed within the organization. Okay, there is another question from Srihari. Srihari is asking, there is an increasing concern about space debris. What measures ISRO is taking to ensure sustainable and responsible space activities in the long term? So we started a special laboratory called IS4OM, ISRO's Sustainable and Safe Operational Laboratory, operational space. And what we are trying to do in ISRO is to look at all the objects in space that are catalogued and available. And this is available through various observation platforms across the globe, and some of this information is available free, and some are charged and available. And using this data, typically of thousands of satellites and objects that are orbiting around Earth, and we do a computer simulation. Every day this is done. And this computer simulation will tell you how they are moving around the Earth and whether they will come closer to each other, that we call conjunctions. And this closer is few kilometers closer, not exactly meeting each other. And with all its error bands, etc. Because every observation has its own uncertainty, hence the prediction also has uncertainty. So when they come very close, like few kilometers, we assess this and then warn the people. It could be our own satellite or it could be somebody else's satellite. And this warning is issued every day. And based on this warning, the satellites will move little bit here and there, so that this warning vanishes in the next cycle of analysis. So this is one activity we are doing. We are also trying to create our own observation platforms like radars. And these radars and optical observatories are important. For us, some of the large telescopes, we can actually see the satellite and see somebody is coming near to it, how it is moving, etc. So this is yet another way of doing it. We are also helping our design teams to create very sustainable operational principles. That is, if a satellite is nearing its end of life, we tell them, yeah, now it has come, time has come, and you should deorbit it like this. And we identify what are the processes required and how to do it. And we have recently deorbited at least 3-4 satellites. Then another method is that we make sure that they are removed of propellants, gases, so that they don't explode like the rocket stages. So all of this we do. So we drive the people from design to operation in every level, so as to make sure the sustainability of space is assured and we don't clutter the space, we don't add more debris. I think it is our word from India, and we have to be an example for the entire world. See, one question Mr. Trinetra is asking. Sir, can you please share some insights on the launch capacity augmentation that ISRO is undertook? Yes. In terms of numbers, I think he is interested in the number of launches that is going to take place. I would like to tell you, Trinetra, the number of launches is a function of the demand now. The market demand, basically the satellites are the users. So the users are more, naturally the launches will be more. And the users are less, launches will be lesser. So who are our users? The users are the customers for who dealing with the television broadcasting, therefore communication satellites. Those are dealing with internet services. And second set of users are the ones who are using the imaging services, the remote sensing satellites. And the third class is the navigation services, which is again government owned. And the lastly is the scientific missions, which is again done by government. Now, so the users are commercial users, the quasi-government users and government users. And based on these users, we aggregate the requirement and build the satellites. And when satellites are ready, rockets are also made ready. So we make an effort to have this as fast track as possible. But then many of the process of building the satellites and launching them takes long cycle time. As you know, a typical satellite from concept to realization takes minimum of 4 years and maximum can be 8 to 10 years. You know, Aditya satellite, which we launched recently, took 8 years to build, conceive and build. The NISR satellite has almost taken 10 years to conceive and build to this level. And rocket typically takes cycle time of 2 years from material procurement to manufacturing and launching. So it's a long gestation time. What we are trying to do today is to find out more users. So who are the